Hi, I'm Tim Hawkinsmith with CMTA Energy Solutions. Thank you for attending our session today here at the 2020 Virtual Winter Symposium by KSBA. Today you're going to hear from Tony Hands and Tracy Stewart with our Louisville Design Office. They're going to share with you some information on zero energy design and other emerging trends in school engineering design that are deployed throughout the country, and especially right here in Kentucky. You're also going to hear from Conrad Cutter. Conrad is a solar specialist with CMTA Energy Solutions. He's going to talk about solar net metering and how it impacts the financial feasibility for solar in projects in places where it works and sometimes it doesn't. And he can explain, I think, why that might be the case. We thank you for being here today. We hope to see you in person real soon. Thanks again.
So as we begin talking about zero energy buildings, the first thing we need to do is explain what the metric is for defining a zero energy building. And to do that, we need to first understand what energy use index is, and it's an EUI. So, energy use index is the EUI of the building, which equals a kBTU per square foot per year. And a kBTU is basically the energy that is consumed by the building per square foot. So you divide it by the square footage of the building, and then you divide, and that's total for an entire year. So it's the kBTU, whether that's converted from electricity or converted from gas, it all can go into a kBTU per square foot per year. And that is the metric that Energy Star uses as we start to look at schools and their energy use, and we start to compare them with each other. The other thing is that now that we understand what an EUI is, or the energy use index it is, our goal is to get that number as low as possible. So the lower the EUI, the less energy per square foot per year the building is consuming. So it's like a golf game. You want the lowest score because the lowest score wins. The other reason that it's important is because when you have a lower EUI and you want to become net zero, you have to purchase less renewable energy, less photovoltaics or PV. So if you have an EUI, say, of a typical building in the 65 range, you have to buy enough renewable energy or PV to achieve 65 EUI. But if you design your building high performance, you move that down, and now you're at purchasing, say, 25 EUI of renewable energy and operating your building at a 25. And that's really how it becomes affordable to create a zero energy building. It's about drastic energy reduction so that you can afford the renewable energy or the PV to offset that. And the other big piece about it is if you get your energy use down to that level, now you can fit all your renewable energy on your roof. You don't need to do any of the site. A typical building, that operates, in the 55 to 75 range on EUI, you can't fit it on the roof. So then you really have to go to other means to be able to do canopies or site mounted, and the cost just becomes very prohibitive. So we are starting to see nationally an increase in the number of school systems that are moving towards high performance buildings and zero energy buildings. And really the first reason for that is the life cycle costs associated with making that decision. So when you are building a new building or renovating a building, it's really not a huge financial difference in a high performance building and a typical building. And basically a lot of it just relies on your priorities and your choices. And so if that is a high priority, it's something that can happen through cost shifting and different strategies. So when you start to look at the life cycle costs associated with high performance, that's really the number one reason, and the reduction in the operational costs for the school districts for the life of the building is a big impact. But we're also seeing a different level of environmental stewardship. And we're starting to see that, the next generation is not going to allow us to continue to waste our natural resources. And so there's a different level of wanting to lead by example, and a lot of pride that people take in the fact that they are reducing their carbon footprint and that they are taking better care of their environment. And it kind of makes a statement for the school district of what is important to them if they do make the decision to go to high performance and zero energy. So really it's a big part of it is the financials, it's about sustainability, and it's about environmental stewardship as well. And when you think about the environment, it's also air quality related, because the less energy you use, the less pollution that's created to create the energy to which you're consuming. And so if you start to think about a school using 30% of the energy of a typical school, that really is drastic energy reduction. It does have an impact on our ability as a nation to address the sustainability goals and the zero energy goals and the carbon neutral goals that we're starting to hear so much about. So one of the clients that I work with is in Florida. It's Osceola County Schools. And what I find to be the most important thing as a zero energy designer is to have someone at the owner level who is passionate about making sure that high performance and zero energy is in design, and challenging the design teams through the RFQs, through RFPs, and throughout the operation to be able to achieve those goals. And so Osceola County Schools, when they put out their RFP for Neo City Academy, they had in there an EUI goal. And they also did the same with Canoe Creek. And both of those had aggressive EUI goals. For the state of Florida, the average is 65 EUI, but this district also has schools that actually perform up to 110. And that is not unusual. I have seen that throughout the country. So our goal is under a 25 EUI. So it's an aggressive goal, and they don't get any additional money. They have a certain amount of money that's allotted per student station in the state of Florida, and that's the amount of money that they're allowed to spend. So it's important to make sure you bring in a design team that can be creative and innovative and understands how to design for a zero energy building very cost effectively. And both of those buildings, one has been in operation over a year and it's operating under a 25. The other one is currently in construction. So one of the things that Neo City did and Canoe Creek was that they had a different envelope. So they invested into a tighter envelope that's building pressure tested. They did mock-ups that are going to be three-dimensional that you could pressure test and find problems with. So they spent some on the envelope, which is very important to drive it out architecturally that way. But then also they went with a different type of HVAC system. Down in Florida, most people do the same thing they've always done since the 1970s with the same design, because that's just what we've always done and then we're comfortable with it. But you really can't expect different results by doing the same thing you've done over and over again. So even though the envelope gets us part of the way there, the HVAC and the lighting design have a huge impact. So the lighting design was done very cost effectively. It actually is more energy efficient, which means it has less watts per square foot, but it also costs less because there were less fixtures with the LED fixtures that we use and how it's dispersed. The other piece is there was a different HVAC system. And really that's the hardest hurdle to get over. The HVAC system has the biggest impact on the energy use intensity, or the EUI, kV2 per square foot per year, like we talked about earlier. And so going with a different type of system, something that does energy recovery, is really hard for maintenance people and facilities people, because now they have to adjust to doing something different. And they have a lot of schools. I mean, there is a lot to maintain. But what we do is we try to design it as simple as we can, try to keep it less complicated. Something that actually, surprisingly what you've done forever is actually more complicated. But sometimes when you're comfortable with something, it seems like it's less complicated. So Osceola County Schools has gone with a different approach. It's something that they've decided to mandate. It's something that they're tracking in their projects, and it's very successful. If you don't have a champion or somebody within your organization that is going to help make the decisions and guide the process in a way that they make decisions where this is something that's important to them, it just doesn't happen. And so I challenge you that are watching this to come up with your champion, someone who's passionate about it, somebody who's going to require it, somebody who's going to make people accountable for making it happen, and also open-minded enough to do something different to make it successful. One of the really neat things that Osceola County Schools did for Neo City, which is the first zero energy school down there, is they put in the CMTA sphere, which is a dashboard that allows us to watch the building live. So you can see the energy use, you can see it daily, weekly, monthly. And what's really nice about that is when you model a building, you have a feel for how it's going to perform. If you model it well and you've tracked things in the past and you validated your models, junk in, junk out kind of thing. But if you know where you want to be and you start to monitor it and you see it's not performing there, you go and search and you find out why. And so people like me who do this all the time, you get a little obsessed because the dashboard is live, the data is there. And if for some reason all of a sudden the HVAC system is now consuming 20% more than you intended for it to do, it gives you a trigger to go find out why. What happened? Something created this change. And we found out recently that they shut off their energy recovery wheel. That we did not anticipate, but somebody overrode it off. Now we got to get it back on. But without the dashboard, sometimes it's really hard to find these things because you're not seeing live data of what's occurring. And so we really recommend as we do projects, as we start to look at, we break it out with lighting and plug loads and HVAC loads, and we break all those out, and you can look at that and the total, and you look at the generation. And another thing we saw, that it wasn't generating enough. And we're like, why isn't it generating enough? Well, we ended up going to the supplier. They went out on site and they found out there was a maintenance issue that needed to be dealt with, and that's why we were low generation. So it's really good if you have something that's giving you live data, because it gives you the opportunity to see things before it's too late. So if you don't have a dashboard, then you're looking at the bill, and by the time you get the bills and you total them up for the year, you've got a whole year, and you're like, well, didn't happen. But if you have live data, you can head things off much quicker. The other thing is nice about it is if you ever want to get online, you just type in Neo City Sphere. But you can also tour the building. So it's a STEM school. It's very neat. And you can see how the building's laid out from a standpoint of an educational standpoint, and some of the robotics courses and different things of that. So some people think you get a zero energy building and it's not innovative and it's not attractive and it's not a good place for learning and it's a box. By far it is not. You can make very energy efficient, very sustainable buildings with very low EUIs by just doing good design.
So at CMTA, we're designing the next evolution of learning spaces. We're designing schools that truly perform. The AE industry has really moved away from designing for certifications. They're looking at designing for performance-based metrics, or those components of the building that truly enhance learning. And the performance-based metrics of that really dive into the building sciences. And that's where CMTA excels. So in moving to performance-based metrics, we're able to achieve a lot more, but yet stay in budget. And this can have a big impact on the building. It can really mean a lot of things. We can enhance the learning environment, we can enhance the environment for the teachers and the staff, but yet minimize the cost and the impact on the budget that it takes to achieve those. And school districts don't have extra money. With the shift in the industry, we're really seeing reduced tax bases, and that crunch is becoming more and more evident. So how can we achieve more, deliver on a building that teaches more, but yet stay within that budget all at the same time? CMTA has designed more than 5 million square feet of zero energy buildings. And we've done that because so many owners have seen that zero energy can be achieved without adding increased cost. If we can drastically minimize energy consumption in a building, then we can look at multiple different procurement strategies for procuring the solar renewables to make the zero energy building possible. Then they've seen that it's been proven that the building can stay within budget, but yet have a positive impact on the environment. And what better opportunity to teach kids than to showcase that the building that they are in can do these things, can reach these goals. So this has really developed an underlying goal and message across many RFPs, across many owners throughout the country. Up in the Northeast, it's becoming more and more prevalent, where zero energy is a big goal. We've just started design on 2 new elementary schools in Connecticut, in Mansfield and Manchester school districts, to create 2, one is a ground up new school and one's a renovation, to showcase that we can stay within budget, surpass the Connecticut high performance building standard, but yet achieve zero energy. Over in Ann Arbor, with Ann Arbor Public Schools, they've passed a $1 billion bond and they have a large goal in front of them to really set the new standard for schools and what can be achieved. And so CMTA has been asked to write the standards on what goals can be achieved. This owner's moved beyond zero energy. They moved past zero carbon and really looked at what is the impact on the building and the built environment that a building and the building process can have. So we're really studying the embodied carbon that goes into a building and making suggestions on how the owner can pay attention to all things in procurement through building a building that has a true positive impact throughout not only the materials of the building, but also the energy consumption that it uses and being sure that there are no combustibles. So this underlying message is even more prevalent in the DC area. So many districts have seen over the last 7 to 8 years that zero energy is achievable, and they've made the decision that all new projects will be zero energy. So in Northern Virginia, with Arlington Public Schools, with Alexandria City Public Schools, Fairfax County, they're really looking to set that new goal of making sure that their buildings do have a positive impact on the environment. And we've seen years of creating zero energy buildings for those owners. DC Public Schools now writes into all RFPs that not only will the buildings be zero energy, but they'll also be well certified. They're really wanting to improve the health and wellness of their students while staying in budget. And then other districts like Loudoun, Montgomery County are looking at how can we drastically reduce our energy consumption in our buildings and make them zero energy ready, but yet still meet the goals of the school district and in the surrounding county, new high reaching energy consumption reduction goals. Neighboring school districts in Howard County, Baltimore City are also doing zero energy successfully while staying in budget and have zero energy goals that have been designed, built, in operation, and some of the best performing schools in the country. So what we've seen is improving design and evolving design. We can do many things that also improve the learning aspects of the space. We can improve the daylighting, we can improve the indoor air quality, and we can improve the health and wellness, not only of the students, but of the staff, the teachers that are in these schools every day. So many groups have held on to these concepts of health and wellness and seeing how can we achieve performance-based metrics in the health and wellness field. So if we can create a more collaborative design, then we can improve all aspects of the learning spaces and still not create an influx on the cost. So we've done this by working to build a better envelope, drastically reducing our air infiltration by 70 to 80% on the total CFM per square foot of leakage, but then also right-sizing the HVAC system and then over-ventilating. We're adding more air into the space, but we're bringing it through an energy recovery and increased filters, both active and passive. All these things are much better for today's design world in this post-pandemic design concepts. We're increasing the opportunity to actively grab the virus or passively filter the virus. Next, we want to improve the daylighting. So past projects have always over daylit classroom spaces. So new technology allows us to look at not only the solar daylighting autonomy of how much daylighting is evenly distributed throughout the space through the entire learning year, but also how to reduce annual sunlight exposure and eliminate the glare that could come into a space and really hinder the learning aspects. So we're achieving great performance-based metrics in annual sunlight exposure, but yet minimizing the annual sunlight that creates glare. We're also really focusing on indoor air quality. So the opportunity to over-ventilate a space above code, increase the amount of outside air into a space, is going to drastically lower our CO2 levels in the building, which improves cognitive thought. With the improved air infiltration and better passive and active filtering systems, we can help prevent against virus spread. But we can also drastically reduce the amount of PM 2.5 and PM 10 particles that are really chronic particles in a space, chronic particulate matter. And finally, we've really moved past commissioning into optimizing a building and its performance. So our group of engineers will get into a room, will trend a building, see how it comes out of morning warm-up, see how the building is functioning, and looking for those opportunities to enhance the operation well beyond what you could do in a standard typical commissioning setup. So building optimization may be the #1 feature in getting a building to truly perform. When all of these processes come together, then you can really achieve drastic energy reduction. And what happens is you also drive down the amount of PV that's needed to make a zero energy building possible. So many of our projects really just started out as a great school where we were trying to enhance the learning environment, where we were trying to showcase that the building could have a positive impact and be a great example for the students on what could happen in this world in terms of having a positive impact on the environment. And then we looked at maybe through different procurement strategies, could we add alternates to the building bid where we could potentially procure the PV if the building came in within budget on bid day. That's happened, and the building came in under budget, and we had enough leftover money in the contingency to make the project zero energy. We've also looked at working with the owner to advise on a power purchase agreement. Could you procure the solar PV through looking at many buildings, many roofs in your district, and do a power purchase agreement with an investor to put solar on the roofs? And finally, we've gone off and created energy savings through other buildings in the district and used that savings to procure PV to place on a building, on a roof with Jennings Creek, and to be able to showcase that you could procure solar to make a building zero energy if you got the drastic energy reduction down to a point where the PV was achievable.
When you have a solar PV system that's installed on a building, let's say a school, on a sunny day, the PV panels will produce a good amount of energy and feed the loads within the building first. Once those loads within the building are satisfied, that excess energy needs to go somewhere. Most PV systems do not have batteries and are just simple grid-tied systems. And so the excess energy is often off-taken by the utility. Through a net metering contract, that utility gives the client or customer a 1-for-1 credit for the excess solar generation. That excess solar generation rolls over from day to day, from month to month, just like rollover minutes. And so if you have a specific day that's super sunny, you might generate 100 credits that day, and if the next day it's super rainy, those 100 credits might be used up right away. Net metering is that billing mechanism that's the 1-for-1 exchange where the utility is buying back that excess energy at the full retail rate. And that's super important when looking at net zero or zero energy buildings because the engineer should size that PV system appropriately. The engineer should look at how much that building is using on an annual basis from an energy point of view, and they should size a PV system to produce that amount of energy on an annual basis. So if we offset 100% of what the building is using through the PV, we've got a zero energy building. So what makes the PV work a lot of the time is the lower ROI, the return on investment. Most PV systems have a a return on investment of 15 to 20 years if you're a school system. This may be better or may be worse, just depending on the specific utility rate. And the net metering contract has a very big impact on the return on investment, because if you're no longer getting a one-for-one exchange through net metering and the utility is only paying you 25 to 50% of the value for the excess solar, that's going to have a pretty big impact on the financial cash flow of a project. So when looking at solar for schools or solar for any building, a net metering agreement with the utility is quite important. Should a utility not have a net metering agreement, that's okay. But those involved need to understand how much the excess energy is being bought back at, and they need to understand the financial repercussions that might have on the project. Some school systems and school officials may not be motivated 100% by the economics of a PV system. They might be motivated by having a zero energy building or a net zero building to give the students, staff, and community an example of what environmental stewardship, what a forward-thinking school system can be about, and setting an example for those students. And a lot of the time, setting the example for those students is showing them that renewable energy and taking electricity or taking sunshine from the sun that's free and generating electricity for their building is more, that lesson is more important than a low return, low payback on a PV system. Net metering can vary by state, and those net metering rules are very dependent on the legislature and the rules that legislature voted on and set in place within that state. All throughout the East Coast, there are states that have extremely favorable net metering rules, like West Virginia, Washington, D.C., or Maryland. Within those states, a building can have anywhere from 500 to 3,000 solar panels net metered, and it makes it very easy to design zero energy and net zero buildings because net metering system sizes are so large. And so getting a high school or a middle school to zero energy with a very extremely favorable net metering agreement is quite easy in those states. What gets a little bit more difficult is working in states where net metering rules may not be favorable or where net metering is no longer in existence. Senate Bill 100, which was passed by the Kentucky legislature in 2019, went into effect January 1 of 2020, and it has an impact on how utilities will be performing net metering moving forward. That is going to have an impact on PV projects throughout the state. Certain school districts may or may not have net metering available through their local utility. And those school districts need to understand and have a conversation with their local utility on how that may impact their motivation to put PV on new buildings, older buildings, and existing infrastructure. At the end of the day, zero energy buildings and net zero buildings can still be built in the state of Kentucky. There are other options through the utilities where these PV systems can be interconnected. The dollar for dollar exchange will likely no longer be available and make things a little bit more complicated. But nonetheless, that should never stop an owner from wanting a net zero or zero energy building, because our engineers here at CMTA specialize in the design of these buildings and take a lot of pride in providing these buildings for clients.
Thank you again for attending today. We appreciate you, and if you have questions, reach out to your CMTA contact if you have one. If not, reach out to me. My contact information is on the screen. We at CMTA hope you have a great conference and a wonderful holiday season, a safe, happy, and healthy one. Thank you again.